Right, well, here we go with Lecture 7. This perhaps is the most intellectually challenging part of the course because custom actions are not trivial. But let's see if we can get you through it with as little pain as possible. Custom actions are a very powerful mechanism that allow us to write reusable Java code that can be used in multiple JavaServer pages. They're sometimes called custom tags. And for us to be able to write these custom actions or custom tags, what we need are three components. We need the custom actions tag to be put into the JavaServer page. We need a tag library descriptor that defines the tag in terms of name and attributes and so on. And we need the Java class that will be executed whenever that tag is encountered in the code. So we have then these three components. The JSP file, the tag library descriptor file, which is an XML file, and the Java file that implements that tag. And let's take a look then at the relationship between them as far as we can. We have in the JavaServer page, first of all up here, a tag lib, which is a directive. One of the three directives that we just haven't looked at yet because the time wasn't right. Today's the day. So we have in this taglib directive a URI, which is the address of the tag library descriptor. And as well as that address, we have a prefix. That prefix is something that will be used within this page to indicate which library we're going to use. Because we could have several of these taglib directives within the page, and therefore we would want to identify which of the several libraries we're using by using its prefix. So whatever prefix is defined here can then be used at the beginning of the tag when we started off. So we have the angle bracket, then the prefix, colon, and then the name of the tag. So that's the beginning tag. There is a tag body, which is optional. In some tags you won't have a body, others you will. And then there's the end tag, which is written in exactly the same way as the beginning tag, but with the usual forward slash in the second position. Now it's also possible that these tags can be designed to take attributes, in which case we would list the attributes here after the tag name and before the greater than symbol. If there is no body, then in true fashion or in keeping with the XML trend, we can just list the end of the tag like this in the beginning tag. So in the JavaServer page we can use the tag, but what happens when that tag is encountered? And it works like this. The first thing that will occur is that the tag, which is listed or identified in the JavaServer page, will have a corresponding entry in the tag library descriptor. So that's what we're going to take a look at for a few moments. The tag library descriptor has a set of XML descriptions for each of the custom tags in the system. So that library, that one file, could describe multiple tags. And for each tag, we would record information such as the tag name, the fully qualified name of the Java class that implements that tag. In other words, it's the code that executes when the tag is encountered in the JavaServer page. We'll define whether the tag body has content or not, and we'll define attributes that the start tag takes, and there is other information that we might encounter in due course. So here's an example. We have the first few lines here, which are just standard. So copy those, paste them in, and then move on. We then have the tag lib tag. This is the root tag, the root element within the XML file. And so there's only one of those per TLD file. We can then define the library version, the JSP version that we're using, and the short name for the library. And then we get to the definition of the individual tags. So for each tag, there will be a tag element in this file. If you've got 3 tags in the library, then you'll have 3 repetitions of that. Of course, this bit, the name element, will have a different value for each of the tags. Here we've just got some tag. This is the name of the tag, and it's that name that will be used in the JavaServer page. Here we've got the tag class that's nominated, and again it's fully qualified, so we'll have the package names and then the name of the class that handles this tag. In this example, the body content is empty. The other permitted value is JSP. And then in this example, we've got one attribute. So this defines a single attribute that belongs in the tag, and therefore we would expect in the tag, whenever it's written, to be to have attra1 equals and then some value. We know it's called attra1 because it, that is the attribute tag, has a name element. It is required. If that's made false, then it's not required, and therefore we'd have to make sure that our tag handler is going to deal with the absence of the optional attribute. And this third part here, the RT_EXPR value, which means the runtime expression value. If that's set to true, then it will permit the JavaServer page to have one of the expressions. If you remember the less than %equals element, the expression element from JSP that we were talking about in the last lecture. And we'll see some examples of the use of this. But it allows us then to dynamically define the value of that attribute. And if the tag is going to have multiple attributes, then there will be multiple occurrences of the attribute element in the XML file. So that's the second element. The tag library descriptor for each tag will identify the class that is going to handle the tag. In other words, it defines the code that is going to be executed whenever that tag is encountered. And so now what we are going to look at is one example, a very skeletal example of a tag handler. We have to, as well as defining its package, we have to import these things here, these packages. And then we name our class in the standard way, public class, and then some name, make it meaningful, of course, so that we can identify that this class is a handler for a specified tag. So quite usually you'll have something like the tag name followed by handler or some other suitable word. Extends tag support. Now that immediately, through the inheritance mechanism, will make this class a tag handler. And it will allow us then to override some of the lifecycle methods and put in our own code so that it will then do what we want it to do at the appropriate points in the execution of that tag. For each attribute that is defined in the XML file, in the tag library descriptor, we will need to have a variable that matches the attribute. In addition, we'll need a set method for that attribute. So in the TLD file, if the attribute name is attra1, then we must have a method called setAttra1, because the system will look for that method and will pass the value that's defined in the tag, or defined at runtime perhaps, pass that value as the parameter, which is then used and is stored in the variable with the matching name. Now, strictly speaking, that name does not have to match the tag attribute. But if you do make it match, it at least helps to identify that this one is going to receive the value that that matching attribute in the tag has got. Sorry, let's move back again. So if you've got 3 attributes defined in the tag library descriptor, you're going to have 3 variables here, and you're going to have 3 set methods. There's also this release method. This is quite typical in that for each of the attributes that you've defined up here, you'll set them to be equal to null, and you'll then call super.release. This is all part and parcel of freeing up this resource ready for garbage collection. Now this is where the life gets a bit interesting, really, because there are some life cycle methods that are called. When the tag is first encountered, after the set methods have been called, the doStart tag method will be called. And then the doAfterBody method, and finally the doEnd tag. Now, doStart tag is going to be called so that you can do some pre-processing, such as validating the values of the attributes to make sure that they are suitable or within range, or they meet the business rules, or whatever it might be. And if you find any problems, then this method needs to return skip body, because that will essentially tell the system to stop processing that tag. Otherwise, you can go on, if there is a body, to evaluate the body and include the output from that as part of the response. In this example, there is no body to process, so it's going then to not call doAfterBody, but will straight away call doEnd tag. But if there is a body and you evaluate it, then doAfterBody will be called after the tag body has been evaluated. I'll show you an example of that in a few minutes so that you can get the idea of how this all hangs together. But this is where you would do any post-processing of the tag's body content. And again, you'll either skip body or return eval body again. Eval body again will essentially set up an iterative execution of the tag body. Then finally, when the tag has finished, we will then, in the doEnd tag, do all the post-processing of that tag, which will potentially do 2 things. One will be to skip the rest of the JSP page because there's been an unrecoverable problem within that tag, in which case the JavaServer page is aborted with an exception. Or we return eval page, which causes the JavaServer page, or the rest of the JavaServer page, to be evaluated, in other words, to be executed. So let's take a look at some examples to see how those elements combine. Remember, there are only 3 elements, so in theory it should be fairly straightforward, but it's all this calling of the lifecycle methods that can make it a little bit tricky. Now in the code that you can download this week, we've got within the one project 2 examples. So let's take a look at example 1 to begin with. Here we have a tag lib directive which identifies the tag library descriptor. That tag library descriptor, as this pathway tells us, is in the webinf folder, which is within web pages, in the TLDS folder, and there is lecture7.tld, which contains the XML to describe the tags. Come back to that in a minute. And the prefix for that library within this page is going to be L7. There it is, being used as a prefix to a tag. Now, don't worry about this underlining here in red. For some reason, NetBeans can get a little bit confused about things. So although it says it can't load the tag handler, more times than not, actually the program will execute correctly. So don't worry too much about those. So what we're going to do here is to get from the request the 2 parameters, num1 and num2, and store them in these 2 variables, num1 and num2. The next thing that happens is that this tag is encountered, and the 2 attributes, num1 and num2, are given the values that are held within the variables that we've just set up here. And this is where we're using the JSP expression element. So the less than % equals num1. So in other words, that's going to end up, let's say num1 has got the value 5. This tag will end up with the L7 : add 2 nums, num1 equals, double quote, 5, double quote. And if num2 has got the value 6, then num2 equals, double quote, 6, double quote. And then attribute name equals sum. You'll notice that that is a literal value, and the reason for that is because of what we find over here in the tag library descriptor. There's the standard first 4 lines, tag lib, versions of the library and the JSP, short name, and then the tag itself. So there's the first occurrence of the tag and its end tag. You'll notice down here we've got another tag defined. That's okay, you can have more than 1 tag in the library. So this tag is called add 2 nums. Its class that handles it is that one there. We'll look at the code for that in a moment. The body content is empty, and then we get the attributes. Attribute 1, attribute 2, attribute 3. The first one is called num1. It is required, and there we have the runtime expression value is permitted, which means then that we can use this JSP expression element to give it its value at runtime. Whereas attribute name, which is the 3rd attribute, that has RT_EXPRA value set to false. Therefore, we cannot use a dynamically generated value. So it has to be a fixed value, a literal value, which is why we've got sum written here. Now, because the body content is empty, then we're terminating that tag immediately. So let's go and have a look then at the class add 2 numbers tag. So we know it's in the package handlers example 1. So here we have in source packages handlers example 1, and there it is, the class. Now what I'm going to do is, so that we can look at things side by side, we'll just arrange things a little bit here. Back in the tag library descriptor, we have an attribute called num1. There's the corresponding attribute with the appropriate set method. Num2 with attribute and set method, and attribute 3 with a corresponding property in there and its set method. Notice set num1, set num2, set attribute name, those are defined essentially by these names here. And all they do, quite straightforward, take the parameter and assign it to the corresponding object level variable. Now, because these are numbers, we need to convert them into integers at some point so that we can use them, because we have to add them together. We can't add them as strings. So why are they set up as strings here? Well, because in the tag, that's how they're going to come to us. Num1 equals, and then the double quote, double quote. So they're going to come to us as strings whether we like it or not. Therefore, we're going to have to do some pre-processing. That string, although it's called num1, could actually be anything. It could be PQZ, for example. And of course, that's not an integer. So when in the JavaServer page, this tag is first encountered, the set methods are called, and once that's been done, the doStartTag method is called. Remember, doStartTag is where we do the pre-processing. So we're going to attempt to parse the string num1. And if it does parse okay, then number 1 will end up with the integer representation of that string. And likewise for num2 into number 2. And if both of those work okay, then data okay is going to be set to true. But if num1 or num2 are not string representations of an integer, then parseInt is going to throw a number format exception, which we're catching here, and doing nothing really, because there's no point setting data OK to false, because it was initialized to false up here. But we could have set it to false if we really wanted to, just not needed. And then finally, we're going to return skip body. We have to return skip body for this one, because even if the data is okay, we've still got to skip the body because the body is empty. And therefore there is no body to process. So this doStart method has got to skip body. So whether the parsing works or not, skip the body. And because we're skipping the body, the doAfterBody method will never be called. And so we come straight into doEndTag. There is no body in here, so that's fine. We can skip the body. The doEndTag will be called essentially once we get to this point in the JavaServer page. So the first thing we have to do is to check if data is okay. If it isn't, then that was a big problem, and so we're going to return skip page, which will abort the processing of the JavaServer page with an exception. On the other hand, if the data is okay, then we're going to take the integer values, number 1, number 2, add them, store the value in result, and then we're setting up an attribute on the page context that takes as the value a new integer called result, a new integer with the value of result, and it will be called, well, that attribute name is a string that came from the attribute here. So the name of the attribute on the page scope is going to be called sum. Therefore, at this point in the JavaServer page, we can call the standard action useBean. The ID is sum because we know it's going to be created there with the name sum, because that's the name we gave it, and that's the name over here in the handler. That's the name that was used for that attribute. We know it's on the page scope because we wrote this bit of code, so we know it's going into the page scope here. And we know it's of type integer because we set it here. So calling useBean at this point is going to set up a variable within the JavaServer page called sum. It's going to find the value for that variable in the page scope and will convert it to an integer object. And therefore, when we get down here into the HTML that's embedded, we can use the expressions here in JSP, num1, whatever value that was, plus num2 equals, and then the value that was calculated over here in the Java file that ended up as a page scope attribute called sum is then used here. So that's an example of a tag handler with an empty body. The three elements have combined so that when this tag in the JavaServer page is encountered, it will be parsed to make sure that it matches the tag definition in the TLD file, the library descriptor. Using these values here, they will then address this class, calling the various set methods for each of those attributes. Then we'll call doStartTag method over in this class. Then we'll call doEndTag, either to report a problem by skip page or to set up a page scope variable, in this case called sum, that can then be used down here. So there's the first example. Relatively straightforward. The other one is slightly more challenging. So let's close that one and open up the other tag handler in preparation for examining it. Oops, sorry, wrong place. Let's close. Let's do it here instead. Right, so example2.jsp. This one is going to output a times table. So it's going to get from the request the value of the table num parameter, store it in the string table, which is then used as the value for one of the attributes in the times table tag. Let's go and take a look at this tag in the library. So here's the tag, times table, handled by the times table tag class, which is this one over here. This time the body content is JSP. In other words, the body is not empty. It's going to have something for us to process. There are three attributes. The table num, which is required and can take runtime expressions. The line ID name, which is required and cannot take runtime expressions. And the result name, which is required and cannot take runtime expressions. Therefore, over here, when we set up the tag, we've got the attribute called table num that takes the current value that came in from the user as a request parameter that has now been picked up and stored in the string variable table. And then the other two attributes define the name of the beans that will be used here and here. In other words, when that tag executes, it's going to produce a value for a variable called line and a value for the variable called product that will then be used within the body of this tag. So there are three attributes: table num, line ID name, result name. And therefore, over in the handler, we've got the three object level variables with their corresponding set methods. We've also got these integers here. Table, which will be the integer of the string held by table num, and line num, that is going to keep count of the times table line that we're dealing with. And data OK is set to false. So again, in doStart tag, which is going to be called as soon as this tag has been set up. In other words, the attributes have been, the values of the attributes have been passed to the handler by calling the set methods. So doStart tag will now execute. And what it has to do is to take the string that holds this table num, parse it, as we did in the previous example, and store the int value in table. If that doesn't parse, we get a number format exception and skip the body. On the other hand, if this does parse OK, then line num is going to be set to 0. Data OK is going to be set to true, because the attribute values have been validated and found to be OK. And then we call this method called next loop. So let's scroll down to that. Next loop simply adds 1 to line num. So the very first time when line num is 0, line num plus plus will increment it to 1. So we're now on line 1. We'll then calculate result based on the current value of line num multiplied by the current value of table. So if the user on the HTML form typed the number 5, that will have come in as a request parameter. It will have been picked up by the JSP, plugged in as the value for the table num attribute on the tag. The string 5 will have been then stored in that variable. Then it will have been parsed back into an integer 5, stored in table, and now is being used in this calculation to calculate. So let's stick with 5 as our value. Line num is currently 1, so 1 times 5 is 5. Result now has got the value 5. We now need to set up 2 attributes. One containing whatever name is held in there, which came from here, so that's going to be called line. So line is going to have the value 1, and product is going to be used here and have the value 5. So that having called next loop here, we then come back up to the doStart tag and return eval body include. In other words, it's an instruction to the JavaServer page to pick up those values and then to use them in the body of this tag. So line is 1, table is 5, product is 5. 1 times 5 equals 5. That's the end of the body. So do after body is now called. And we check to see what value line num has. Well, it's got the value 1, which is less than 12. And therefore, we call next loop again, which will increment line num. That's now got the value 2. Calculate result. That's now 10. And set those scope attributes, page scope attributes, again. And then, having done that next loop, return eval body again. In other words, come back to here and start evaluating that tag body all over again. But of course this time, because we're using the beans again and fetching them again from the page scope, it means that we get the new values. 2 for line, 10 for product. So we get another table row being output in the HTML. 2 times 5 equals 10. That's the end of the body, so do after body is called again. And so it goes on until that condition fails. It becomes false. At which point, we don't bother incrementing and setting up another product. We simply return skip body. That's the indication then to the JavaServer page to stop executing this tag. And so it comes then to the end of the tag. Therefore, it calls the doTag method. Now, what's been happening all this time is one of two things. If there was a problem in the doStart tag because the string for table num was not an integer, then data OK will still be false. The other scenario is that there wasn't a problem. The tag body has been executed several times and has been producing output for the JavaServer page. But the output has not actually been put into the JavaServer page's output stream. It's been buffered, it's been held in a temporary area. And the reason for that is, even at this stage, there might be some checks that have to be done that after the body has finished being executed, those checks might say, actually, there's still a problem, and therefore, the output from this tag should not be sent to the JSP output stream. In other words, all the way back to the web browser. And so we've got a choice to make. If data is OK, then we're going to essentially redirect the buffered output from this tag, and redirect it into the JSP's output stream. And so this is what happens here. If the body content is not null, in other words, if we've actually generated some output from this tag, then we will attempt this, get previous output. In other words, because the out has been redirected into the buffer, previous out is actually the real output stream back to the web browser. So get previous out will now give us the print writer for the web browser. And we can then print, in other words, we're going to send to the web browser the body content as a string. So all of these table rows that were being supposedly output never went back to the web browser because the output stream had been redirected into the tag's buffer and had just been stored in there. And so over here in the doEnd tag, what we're doing is getting hold of that buffered content from the tag body, and now we're printing it to the JavaServer page's output stream. When all that happens successfully, we'll then carry on evaluating the rest of the page. And of course, the release method is going to set everything to null so that the garbage collector will pick it up and dispose of it. So this particular tag is iterative, and it's only iterative because of this bit in the doAfterBody. It's got a condition which, while that is true, will keep returning eval body again. And so it goes back to the beginning of the tag, evaluates the tag body again, and then doAfterBody is called again. So every time that returns eval body again, that tag body is executed. So it keeps iterating and iterating. There's no while loop in there, at least not that we can see. But if we were to have a look at the JavaServer page's servlet that is generated, what you will find in there essentially is a while loop that says, while eval body again, do this lot. And at the end of doing this lot, there will be, in the generated code in the servlet, another call to doAfterBody. So we're not actually seeing the full picture. We're not writing the full picture. We're making use of the knowledge of what gets generated in the servlet. And then eventually, when doAfterBody returns skipBody, that will cause the while loop that's been generated into the servlet to terminate. And then at the end of the body, there will be, in the generated code in the servlet, a call to doEndTag. And that's really how this tag ends up being iterative. So 2 examples. One of a tag without a body that doesn't iterate. And this second example of a tag with a body and it iterates. Of course, you could have a tag with a body that doesn't iterate. That's okay too. In which case, what you would have is the doStart tag would return eval body include, so that the tag body is evaluated, at the end of which doAfterBody will be called, and whatever code you put in there, because you don't want it to iterate, you just call skipBody immediately, because that will then kick us straight out of the body and cause doEndTag. Okay, so it's the iteration is effectively set up simply because we're returning eval body again. And there we have it. Those 2 examples that explain how the tag library descriptor, and the Java class that is effectively the tag handler all work together. Good luck with the tutorials. It will be the most challenging of all the tutorials on this module, and that's why it's got a few more marks allocated to it. Good luck.